Okay, welcome back. Dr. P here, and in this lecture I'll talk about reactions of alkyl halides. Now, there's a couple that we're going to look at in more detail in Chapter 11, and those are nucleophilic substitution and elimination. So I'm not going to talk about these in this lecture. But what I am going to talk about is Grignard reagents and what does the text call it? Organometallic coupling reactions. All right, so let's take a look at those. So it was discovered that if an alkyl halide is treated with magnesium in an aprotic solvent, so ether, we'll end up with something called a Grignard reagent. We would actually refer to this one as ethyl magnesium bromide, or the ethyl Grignard. And this was actually this reaction, the Grignard reaction and the Grignard reagent, are named after Victor Grignard, who did this work on these reagents as his doctoral dissertation, and won the Nobel Prize in 1912. So that'd be kind of cool to, have your PhD thesis win you a Nobel Prize. And so what he actually looked at was phenyl magnesium bromide. And reactions with that. So let's actually take a look at this. Let's focus in on the structure of our Grignard. All right. So we do have a polar bond here. The carbon-magnesium bond is polar. Carbon is much more electronegative than magnesium. So we would get a delta plus, where the magnesium is, and a delta minus, we'll do delta minus, where the carbon is. So it turns out that that bond is nucleophilic. Or rather, those electrons are nucleophilic. In fact, I always found it helpful to think of Grignard reagents and other organohalides as reacting like a carbanion. Okay, so that carbon-magnesium bond there, it really functions like a lone pair with a negative charge. So this is highly nucleophilic. It's also very basic. And so what would happen is you do something like MgBr plus double bond O, add it to a ketone, or it could be an alkyl halide, and you would do this in two steps here. So one, we just use ether as the solvent, and two, we quench with acid. And I'll show you the mechanism in just a minute. And we will get a new carbon-carbon bond. So that's the power of the Grignard reagent, is that we get a new carbon-carbon bond forming. So we can turn an alkyl halide into a Grignard just by adding magnesium. And then that Grignard can react with a ketone or an aldehyde, some kind of carbonyl, to give an alcohol. We'll talk more about that in the alcohols chapter, but it is something just to think about. We could also, my MgBr plus, let's use another bromine there, and we'll just react that in ether, and we will get, so that carbon's going to be attached to that one. So 1, 2, 3, so 1, 2, 3. And then we end up getting MgBr2 as a solid product. So this is a way to alkylate things. So here's my new CC bond here. And we saw acetylide ions working as nucleophiles. And this can do the same thing, only they're a lot more reactive. So let me just show you the mechanism here, and then I'll just mention some other types of organometallic coupling reactions. So the first step is done in ether so that the Grignard doesn't react with anything else. And we'll get nucleophilic attack from the electrons in that carbon-magnesium bond on the carbonyl carbon. And that'll kick the electrons up onto the oxygen. So now what we'll end up with is CHHO minus. And then we'll add acid. So it's important to do this in 2 steps. If you simply added the acid right away, the acid would quench the Grignard. Because the Grignard, remember, if it's reacting like a carbanion, that's a good base too. So this will go ahead and just be quenched by alcohols, water, acid, a lot of different things, amines. And so, well, protonated amines. Anyway, so we'll go ahead and get our proton transfer there. And now, as our final product, we will have CHOHH. Okay. And again, the it's actually MgBr. MgBr falls off. And then that combines within, I think, within OH. Anyway, we end up getting a salt. It's a solid that you can then dissolve in water. So just to remind you guys, this is our nucleophile, or our Lewis base. And this is our electrophile, or Lewis acid. And note that, if we were doing the reaction with an alkyl halide, we wouldn't have that extra adding the acid step because we wouldn't need to protonate the oxygen because there wouldn't be one. Now, there are some other organometallic coupling reagents, and these include things like let's say alkyl lithium. So if we had something like say we reacted our 1-bromobutane with lithium here, we'll end up with plus LiBr. And butyl lithium is then both a good base and a good nucleophile. Another one that we can use is the Gilman reagent. And what's the Gilman reagent? Well, the Gilman reagent is a lithium dialkyl cuprate. So this is lithium dialkyl, the dimethyl in this case, cuprate, which you could just call a Gilman reagent. And both of these will work as nucleophiles. Gilman reagent actually doesn't work as a base that well, although you wouldn't want to react it with alcohols. So, for example, you could do react your butyl lithium with ethyl bromide and get hexane. We could react, let's say, we could react, I don't know, 2-bromopentane with our Gilman reagent, our methyl Gilman reagent, and get now a methyl where there was a bromine. So these are good at doing alkylation. So also work. Gilman reagents will also add to carbonyls as well. Okay, so the great thing about these is that we've now learned a good way to make carbon-carbon bonds. And really, when we're trying to synthesize molecules, that's one of the most important things, is being able to build up a larger molecule from a bunch of smaller ones. And in order to do that, you need to make carbon-carbon bonds. So chemists are always out for ways, looking for ways to make carbon-carbon bonds. And the Grignard reaction and other organometallic coupling reactions are great ways to do that, so especially the Grignard. And in fact, you guys will get to do your own Grignard reaction in the start of, or at the start of 12B next semester. All right, so that wraps up Chapter 10. You can go ahead and read about it in the text as well. There are a few more details, such as how to prepare Gilman reagents, some other more esoteric, a little more esoteric, what was I going to say, coupling reactions. There is a section, section 10.8, oxidation and reduction in organic chemistry. I think I'm going to talk about that in Chapter 17. So I'll talk about redox reactions a little later on. So for right now, this is Chapter 10. And until next time, stay safe out there. Bye now.